Section 5.3 is about dividing polynomials. Here we have a polynomial divided by a monomial. When that's the case, easiest thing to do is to divide each term of the polynomial by the monomial separately. So we'll rewrite this in a sense as three separate fractions, all of which dividing the monomials by the same 4xy. Now we'll simplify each fraction individually. 4's will cancel. Here there's 3 x's on top with 1 on the bottom. So you're left with an x squared on top, and there's 2 y's on top, 1 on the bottom with 1 y on top. 8 and 4 goes into 8 twice. The x's will cancel. Y squared over y means a 1y on top. 4 goes into 12 3 times. 1x on top, and then y cubed over y means a y squared on the top. There are no like terms, so this would be simplified. Here we're going to divide by something other than a monomial, in this case a binomial. When we do that, we're going to use long division just like we used in grade school. So we'll divide z squared plus 2z minus 24. We will divide that by z minus 4. So we take the z and divide it into z squared. So I'm asking myself, if I take the z squared and divide it by the z, what do I get? Well, I get a z. That goes on top of the z column. Remember, you want to keep all the columns lined up. Now we'll take the z and we will distribute it. Z times z is z squared. Z times negative 4 is negative 4z. Always subtract in long division so that you cancel those out. 2z minus negative 2z, that's really a plus, so I get a 6z. Now I'll bring down the 24. Now I have to divide the z into 6z, and if I divide 6z by z, I get a 6. And where do I put the 6? I put it in the column that has all the whole numbers. So distribute, 6 times z is 6z, 6 times negative 4 is negative 24. And in this example, I get a remainder 0. So my answer will be z plus 6 with no remainder. If I did have a remainder, I would write it with the number, in this case 0, over z minus 4. This is what you would write if it was a remainder, but in this example we didn't have a remainder, so you don't have to do this. Another method you can use to divide polynomials is called synthetic division. I'm going to show you how to do that. You're first going to take the dividend, the thing you're dividing into, and you write down the coefficients in descending order. So I'm going to use 5, negative 13, 10, and negative 8. If any of those were missing, then you would put a 0 in place, but we have them all in descending order. Then on the left side here, you make a little box, and you're going to put the constant term of the divisor. Now here's my divisor, and it has to be in the form x minus r. That's the form that the divisor has to be in, and if it's not, we have to write it in that form. So it's always got to be a minus, and then you're going to take whatever's after the minus sign, and you're going to put it in this little box. So this is how you start synthetic division. Now put a bar underneath here, and the first thing you do is you bring down the 5. You add 5 plus nothing, and you put a 5 here, and now you're going to multiply. 2 times 5, and you put your answer right here, 10. And now you add. Negative 13 plus 10 is negative 3. Then we're going to multiply again. 2 times negative 3 is negative 6. And then you add. So we get a 4. And then 2 times 4 is 8. Put it right here. And then we add. We get a 0. Whatever you get here is the last number. This is my remainder. In this case, the remainder is 0. Now, what's the answer? The answer is these coefficients down here, but you take one less exponent than you see at the beginning. So because this is an x cubed, I'm going to start my answer with an x squared, and then a negative 3x, and then a plus 4 with no remainder. So that's how you solve this using synthetic division. Here's another example using synthetic division, but it's a much more difficult example. And one of the reasons is because your divisor isn't of the form x minus r, like we said it needed to be. Well, here's what we do. We're going to take this and divide everything by 2. So we're going to make this new divisor x plus 1/2. And now that is of the form x minus r, it's x minus 1/2. Now if we do that, if we divide by the 2 here to help us use synthetic division, we also have to divide everything in the dividend by 2. If I do that, I end up with a new polynomial of 4x to the 4th minus 2x squared. This is plus 1/2 x over 2 is 1/2, plus 2, and that now is divided by my x plus 1/2. So we make some numbers that are a little more complicated, but now we can use synthetic division. The other thing that makes this a little more complicated is that it starts with an x to the 4th, but it goes right to an x squared. So when I write my coefficients in descending order, I start with the 4, but then you have to put a 0 down because we have to make room for the x cubed column. Then we take a -2, we take a coefficient of 1/2, and then a 2. Remember, the box out in front is this number here after a minus sign, because I can write this as x minus -1/2, and that means in this little box I put -1/2. So now let's use synthetic division. 4 plus nothing is 4. Multiply -1/2 times 4. I'm going to get a -2. Add those together, -2. Now we multiply -1/2 times -2 and get a positive 1. Add those together, get a -1. Multiply -1/2 times -1, you get a positive 1/2. Add those together, get a 1. And then multiply -1/2 times 1, you get a -1/2. So 2 minus 1/2 is 3/2, or 1 1/2. That's my remainder. So let's see what the answer is going to look like. Remember, we started with an x to the 4th, so my answer is going to be a 4x cubed minus 2x squared minus a 1x plus 1. And then my remainder is 3/2 divided by the x plus 1/2 of my divisor. Now there's one more thing I can do to simplify this a little bit further. And that's put this remainder back in the form that it should have been. Remember, at the very beginning we divided everything by 2. So let's multiply everything by 2 to put everything back. So we cancel this. So my remainder is actually going to be 3 over 2x plus 1, which is what we started with a 2x plus 1.